This is Geometry, Unit 8, Day 14. We're talking about the area of sectors. The area of sectors is very much like the same calculations as when we found the length of an arc. A sector is the area that is bounded by the arc and the central angle. We're talking about the area of the circle in that region. That's a sector. So to calculate the area of the sector is the portion. Pi r squared is the whole portion of that same type. So pi r squared is the area of the circle. And this is going to be proportional with the central angle and 360. So as the angle gets bigger, the area of the sector gets bigger at the same rate. We see two different ways to phrase that same formula. The area of the sector over pi r squared. The arc measure. Arc measure, recall, is the same as the central angle. In most of our pictures, we will find the angle measure at that central value. So that's why I like to focus my formula as a central angle. So let's use that formula to answer several of these questions. We're going to take sector over pi r squared equals the angle over 360. Sector over pi r squared, the radius is 5. So pi 5 squared equals our angle, which is 63, over 360. To calculate this, we're going to cross multiply because it's a proportion. We really only have to cross multiply the one direction because that gets our sector by itself. 25 pi times 63 over 360. And using your calculator, you should try to type this into your calculator and you'll come up with 13.7. We don't have specific units for this figure, so we just call it units squared, because area, a sector, we're referring to the area of the sector, would be units squared. Here's our next figure. Our formula that we want to be familiar with is sector over pi r squared. We're looking at the area of the sector, the central angle of that same region over 360. So we're still trying to calculate what that sector area is. We know the radius. So the radius is 9, so it's pi r squared, so 9 squared. 106 is the central angle over 360. We cross multiply to get sector equal to 81 pi times 106 over 360. So the sector's going to be 74.93. These units are feet. So because a sector, we're referring to it as the area of the sector, that is feet squared. For this example number 2, we're looking for the area of the circle. Circle M, that tells us that that's the center letter of the circle that we're working with. The area that they refer to here is the area of our sector. We're going to use the same formula, sector over area. You can use a capital A, you can use an X, write the word area. You could even write pi r squared if you wanted to. So the same formula we were working with before, we're just not as specific about what the area is because we don't have a radius to plug in. We have a sector area over the area of the circle. I still don't know what the area of the whole circle is. The angle for that same shaded region is 58 over 360. So when you solve this proportion, we would need to cross multiply both directions because we're trying to solve for area and we need area on top of the fraction. So 3607 times 360 is going to equal the 58 times the area of our circle. We'll divide by 58, and that crosses that out. So the area of the circle is going to become, we know the area of the circle has to be larger than the area of the sector. This angle is almost 60 degrees, and 60 times 6 makes 360. So we would be multiplying this by almost 6. So it's going to be considerably larger. It ends up coming up with your calculator as 223.9 centimeters squared. Be sure you know how to use your calculator to type that in. You type it in just the way it is. This question's a little tricky. First of all, they're asking for the diameter. I don't have the radius. I don't know what the diameter is. They're giving me an area. The area is of the shaded region. They're giving me an angle, but the angle is not of the shaded region. So we first need to figure out the angle. So we're going to take 360, which is the entire circle. We'll subtract the 109 to get 251. So it's 251 degrees for this central angle. So for us to now find diameter, we first need to find radius. And then we're going to times that by 2. To find the radius, we have to figure out what the area is. So we'll start out with sector equals pi r squared. 251 is our angle over 360. We don't know what the radius is. Our sector is actually 72.39. So we'll cross multiply. So 72.39 times 360 equals 251 times pi r squared. We'll divide that by 251 because we're trying to get the radius by itself. And this will give us a value of 103.83. That is what's left on this side, which is pi r squared. Now to get the r by itself, we need to move the pi across. And that'll come up as 3304, which is r squared still. So now, how do we get the r by itself? I have a number being squared to equal 3304. I need to know what the actual radius by itself is. So you take the square root. That gets r all by itself. So using your calculator, you figure out that r is 5.75. That makes the radius twice that, which would be 11.5, and the units are feet. It's not feet squared because this is a distance. It's a diameter. It's a distance all the way across the circle. Here's our circle we're working with. We're told about this circle that the area of the circle is 295.52, and the area of this sector is 55. We need to answer these 4 questions. So we're going to look at the radius of the circle. To figure out the radius of the circle, in the past, we've had to use the whole proportion and try to solve to figure out what the radius was. But that's because we didn't know what the area of the circle was. They give us the area of the circle. So we're able to say that pi r squared equals 295.52. We don't have to use the whole proportion. We already know what the area is. So we'll divide by pi. That gives us an r squared, which is 9407. So we'll take the square root of 9407, which comes out to be 9.7. And our units are inches. So there's the radius of our circle. What do we need to do to figure out the circumference of a circle? There's a formula to use for circumference. C equals 2 pi r. So C equals 2 pi times 9.7. That gives me an exact answer of 19.4 times pi. That would be our exact answer. And with a calculator, we would come up with an approximate value of 60.94. And because this is circumference, it's a distance, those would just be inches. Next, we're going to figure out the measure of arc PQ. What does it mean for the measure of an arc? You can't answer these questions if you don't know what it's asking. We have an arc, which is PQ. The measure of that is the degree. The degree is the same as the central angle. So if we know the central angle, then we know what's considered to be the measure. That's different than the length. This question asks length, this question asks measure. Measure is a degree value. So, since we already have the sector value, we already have the area of the circle. We're looking for the angle, and that's always above 360. The sector area was 55, 295.52. equals the angle. We don't know what that angle is quite yet. So we want to get the angle by itself. So to solve, we need to cross multiply that way. So 55 times 360 divided by 295.52 equals our angle. So our angle, using your calculator, comes out to 67 degrees. So now, to figure out the length of the arc, we're going to use the formula that measures or that calculates the length of an arc. That's arc length over circumference, which is 2 pi r. Notice the difference between the formula for area and the formula for circumference. Equals the angle we just calculated over 360. So we're looking for arc length over circumference. Well, we know the circumference from earlier. That was 1694. Or we know the radius from earlier, and you could plug that in for your 2 pi r, whichever way you like to do it. Your angle from earlier was 67 over 360. We'll cross multiply so that the arc length of PQ is 67 times 60.94 divided by 360. And then that final answer is just about 11.34. This is an arc length, so it's not area, so it's just inches. So our last question, we're trying to fit this cube, which has the same length sides in every direction, into the circle. We know that the circle has a diameter of 4. So for a square to fit into the circle, we often say that a square peg can't fit into a round hole. But that's if the length of the side was the same as the diameter. That wouldn't fit. But if the diagonal was the same as the diameter, it would pretty much just slide, touching the edges right through. So the face that has to go into the circle first is a square. And we're looking at this diagonal that is 4 inches. We know it's a square, so it's going to have a right angle. What else we know about a square is that the diagonals bisect the opposite angles. So if you just look at the triangle there, that has a hypotenuse of 4, if the 90 was divided in half, that would become 45. So now we have a 45, 45, 90 triangle. And if you remember our formula from the past, the hypotenuse equals the leg times root 2. So hypotenuse is 4. We're trying to figure out the length of the side of the cube. So that's these sides, and they should be the same. So those are the legs of your right triangle. So to figure out the length of the leg, the x, we're going to divide by root 2. So that leaves me with 4 root 2, which would come out to be 2.83. and those units are in inches, because this is the length. This is the length of the side of the box. Now notice how 2.83 is a decimal. The real answer was really 4 divided by the square root of 2. 4 divided by the square root of 2 is pretty good, but it's not in a proper format. To get an exact answer and to have it written properly, we would have to rationalize the denominator. So that's 4 times root 2 over root 2 times root 2 is root 4. The square root of 4 is 2, and you can reduce to call it 2 root 2, and those would still be inches. That would be the exact answer.